And in today's episode, among other things, you'll see a very curious study where artificial intelligences were put into war simulations. And in many cases, they chose nuclear escalation over diplomacy. We're also going to talk about an electric car capable of generating its own energy directly from the sun. And it's now entering mass production in the United States. And meanwhile, in Australia, the police are already using drones operated from hundreds of kilometers away to respond to crimes and emergencies in real time. And obviously, we also have more humanoid robot models starting to work in real factories. And at the largest particle accelerator on the planet, scientists have created a small robot that is capable of exploring extremely narrow pipes to help keep the Large Hadron Collider running at full capacity. Let's understand all of this. Hello, impressed gentlemen and ladies. I am Realidade Impressionante, and you are watching Realidade Impressionante. Yeah, I know. I admit that in the last few episodes I've talked a lot, maybe even too much about humanoid robots. But that's exactly what the world is producing at a fast pace. And understanding what's happening helps us understand the possible future that's already arriving. The BMW Group, for example, announced a new pilot project at its factory in Leipzig, Germany, where they are already testing the humanoid robot called AEON. Their idea is ambitious: to use robots in a human-like way to perform heavy and repetitive tasks in automotive production, tasks that were previously done exclusively by humans. AEON was developed in partnership with the Swiss company Hexagon Robotics, and it was designed mainly to work on assembling high-voltage batteries used in electric vehicles. These tasks require precision, strength, and constant repetition,
E é exatamente o tipo de trabalho.
where robots can have a great advantage. The project is part of a much larger strategy by BMW called Physical AI. This concept aims to connect digital artificial intelligence with the machines that operate in the real world. Instead of just analyzing data, AI now directly controls the robots and physical systems inside the factories. Before reaching the factory floor, however, AEON underwent intensive training in virtual environments, using NVIDIA's simulation platforms such as Isaac Sim. Promotion, navigation, and manipulation of objects in digital worlds that exactly replicate the real factory. This simulation training drastically reduces the time needed to prepare the robot. What used to take months can now be done in just a few weeks. In the real world, AEON uses an advanced set of sensors and cameras that capture spatial data from the surrounding environment. This information is processed in real time by computers embedded in the robot. These are based on the Jetson warning chip, also from NVIDIA, allowing the machine to process, make decisions, and perform tasks with precision. It can also connect to the factory's digital twins. If the tests continue to yield good results like the ones so far, BMW plans to expand the use of this type of robot to different areas of its production. So, have you ever wondered to what extent these machines can replace more complex human tasks, the ones that are harder to perform? Some startups are already trying to speed up this transition much faster than we were imagining. Instead of focusing on demonstrations, the company Nubble Machines, based in California and formed by former SPACEX engineers, decided to put its robot directly to work in the industry. The company was founded just 18 months ago, but it's already attracting a lot of attention behind the scenes. Their team brings together engineers who have worked at companies beyond the mentioned SPACEX, and also includes former staff from Apple, National Aeronautics, and Space Administration and Caltech. The company revealed that its main humanoid robot has already been deployed in industrial operations for a major company, although the client's name has not yet been disclosed. The focus of the project is not on aesthetics or human behavior. The goal is to perform tasks that the industry itself describes as monotonous, dirty, dangerous, and in decline. These are jobs that many companies are having difficulty filling with human labor. The robot can carry up to 27 kilograms, can operate for about 5 hours on a single charge, and is able to move very well in chaotic places like construction sites, for example, climbing stairs and crossing metal structures. All of this has been proven. It is controlled by an embedded AI system running on a single NVIDIA Jetson Warren computer, which coordinates the robot's entire movement. According to the company, the system uses a body control model guided by artificial intelligence, which allows the robot to learn new tasks by observing human demonstrations. Using simulations based on the NVIDIA ISAC platform, the robot can acquire new skills in just a few hours, a process much faster than traditional industrial automation systems. These details have drawn industry attention, but creating a robot that can carry weight or operate machines is just part of the challenge. The real goal of many engineers is much more ambitious: to create machines capable of understanding us, human beings. And for that, some researchers are creating huge databases with human faces in 3 dimensions. Let's check this out now. As humanoid robots become much more advanced, a curious challenge starts to emerge ahead. How can we make a machine recognize and even reproduce human expressions in a truly natural way? Smiles, micro-expressions, subtle movements of the eyes and also the mouth. All of this is part of human communication, but it's extremely difficult to replicate in artificial systems. However, now Chinese researchers may have taken a very important step in that direction. A team led by scientists from the Chinese Academy of Sciences has developed one of the largest 3-dimensional facial databases ever created. The project gathered about 200,000 high-fidelity 3D facial scans, captured directly from real human faces. This data forms a huge set of geometric information that allows for a very precise study of the structure of the human face. Unlike traditional facial recognition systems that rely on 2-dimensional images, this new model works directly with 3D point clouds. In this type of representation, the face is not just an image with texture, but rather a collection of thousands of points in space that describe the exact geometry of the face. To interpret this data, the researchers developed an artificial intelligence model called CFGAT. It was designed to analyze these 3-dimensional structures much more efficiently. The system uses a graph attention network that can identify very subtle variations in facial curvature, essential details for detecting facial expressions, and anatomical reference points. In practice, this allows for much more precise localization of regions like the eyes, nose, mouth, and expression lines, even when the face is moving, which is usually the case, right? This can have very important implications. Humanoid robots, digital assistants, and virtual avatars will be able to interpret human expressions in a much more natural way. In addition, biomimetic systems could become much more accurate in identifying people. Well, the database also includes information about dynamic facial expressions in 4D, as well as complete 3-dimensional models of the human body. Yeah, my friends, deep down this research shows something really interesting. For robots to seem more human, it's not enough to just teach artificial intelligences how to think. It's also necessary to teach machines to understand the geometry of the human face and body itself. But the more advanced artificial intelligences become, other questions arise. How would they act in a nuclear war, for example? Well, let's take a look at this now. A recent study revealed something unsettling. When artificial intelligence systems are placed in simulated nuclear crisis scenarios, they tend to choose military escalation much faster than humans would. The research was conducted by Kenneth Payne, a professor at King's College London, and involves some of the world's most advanced artificial intelligence models participating in strategic war simulations. Among the systems, the most famous were Generative Pre-trained Transformer, 5.2, Gemini 3 Flash, and Cloud Sonnet 4. Each model took on the role of a world leader in a hypothetical international crisis. During the simulations, the AIs had to analyze the military scenario, predict the adversary's behavior, and make strategic decisions, just like a government would do in a real situation. The result caught the researchers' attention. In about 95% of the scenarios, the models ended up choosing to use or signal the use of nuclear weapons instead of seeking diplomatic negotiations. The simulations included territorial disputes, first strike crises, and situations involving the survival of political regimes. In each round, the artificial intelligence had to make 3 main decisions: assess strengths and weaknesses, predict the opponent's next move, and choose its own action. And there was an interesting detail. Each decision had 2 parts: a public statement, where the model explained its diplomatic position, and a private action, which represented the real strategy, what would actually be done. And this showed that some AIs even publicly declared that yes, their intentions were quite peaceful, but behind the scenes, they were secretly preparing for a physical attack. The researchers also observed differences in behavior among these models. Some adopted a more calculated and strategic approach, while others became extremely aggressive when deadlines or pressures increased. In some cases, the behavior seemed almost unpredictable, alternating between signs of peace and threats of destruction. It is true that the study does not mean that artificial intelligence is ready to make real military decisions, but it reveals something very important. The strategic logic of machines can be very different from human logic, even though it was created by us, human beings. And as artificial intelligence begins to influence political, military, and economic decisions all around the world, understanding how these machines think may become one of the most important tasks of our era. Fortunately, not all applications of artificial intelligence point towards scenarios of conflict. Many of them are already being used to solve much more practical challenges, such as one of the biggest questions in modern mobility. Could a car generate its own energy to be able to drive around? The company Aptera, based in San Diego, announced the start of mass production of its first solar-powered electric vehicle. The model has just come off the company's assembly line, marking the transition from handmade prototypes to a structured industrial process. The new production line was designed with 14 assembly stations, allowing for repetitive builds, quality control, and preparation for in-house manufacturing. These first vehicles will not be sold immediately. They are part of a validation line, used to test the cars under extreme conditions before delivering them to customers. The tests include thermal evaluations, brake tests, and even destructive tests, all of which are necessary steps for regulatory certification and approval by the American Environmental Agency. Key to this project is the vehicle's concept. The car features body-integrated solar panels that generate energy from sunlight. According to the company, under ideal lighting conditions, the panels can add up to 38 kilometers of range per day, without the need for charging from an outlet. In other words, for many urban trips, the vehicle can operate almost without needing to be recharged. And even when it does need additional energy, the performance remains quite impressive. The model offers up to 643 kilometers of range with fast charging in less than an hour. The company is already planning a future version with over 1,600 kilometers of range. Although it may seem like an experimental project, the demand already exists. Aptera says it has received almost 50,000 reservations, representing a potential of more than $2 billion in sales. While new technologies are starting to transform transportation, others are completely changing the way cities monitor safety in emergencies. And in some places around the world, drones are already being used as the new eyes in the sky. Batman has arrived there. Imagine an emergency situation happening in a small, isolated town, and the first aerial response doesn't come from a manned helicopter, but from a drone that automatically takes off from the roof of a police station, and it's piloted by an operator located almost 600 kilometers away. This is exactly the experiment that's being tested right now in Australia. The police in the state of New South Wales have started a pilot project called Polware Rural, created to improve response times in rural areas and small towns. The testing ground is the city of Moree, with just over 7,000 inhabitants located 600 kilometers from
ao noroeste de Sydney.
Drones were placed on the local police station's roof. They stay inside an automated station, which is capable of opening, launching the aircraft, monitoring the mission, landing, and recharging the battery, all without human intervention on site. But the most impressive detail is in the control. The drones are operated by certified pilots who are in an operations center in Sydney. That's hundreds of kilometers away from where the drones are installed. From this center, the operators receive live video transmissions from the aircraft and can monitor incidents in real time. At the same time, the police officers on the streets receive exactly the same images. This creates a kind of shared aerial view of the operation. According to the Australian police, this is the first time in the country that police drones are operated completely remotely, meaning there is no pilot present at the location. The equipment used are DJI Matrix 4 3D drones, which are equipped with high-resolution cameras and advanced imaging systems. They can be deployed within minutes when an incident occurs. For example, during a break-in, the aircraft can fly over the area and provide a complete view of the situation to the officers on the ground. This feature is also being used to track stolen vehicles, thus allowing the police to follow the suspect's movements from above. With this, it is often possible to avoid high-speed chases, which pose risks both to the police officers and to the public. Today, it's a drone, and in the near future, will the skies of our cities be filled with electronic eyes watching everything in real time? The answer is pretty obvious, right? Well, let's focus now on robots hidden inside one of the most complex scientific machines ever built by humanity, the Large Hadron Collider. Located at CERN on the border between France and Switzerland, the Large Hadron Collider has 27 kilometers of underground tunnels, where particles are accelerated to almost the speed of light. But keeping a machine of this size running is not a simple task. Inside, there are extremely narrow pipes where the particle beams pass through. These tubes operate under extreme conditions, with temperatures close to minus 271 degrees, almost absolute zero. And this happens in an ultra-high vacuum environment. Any small deformation or failure in these components can compromise scientific experiments that are extremely delicate. The problem is that inspecting these structures manually is a time-consuming and expensive process. Often, it would be necessary to disassemble entire parts of the accelerator just to check for a small defect. Engineers from CERN and the United Kingdom Atomic Energy Authority's Robotics Center Remote Applications in Challenging Environments addressed this challenge. They developed a very curious robot, a small device only 20 centimeters long that is nicknamed the Pipe Inner. Because of its elongated and agile shape, many are already comparing it to a robotic rat. The robot was designed to move autonomously inside the collider's pipelines. It can pass through spaces only 3.7 centimeters wide. During inspection, it captures high-res images of each accelerator module's internal structure, analyzed by artificial intelligence algorithms trained with real data from the Large Hadron Collider itself. The goal is to identify small deformations or anomalies before they become bigger problems. The Pipe Inner was designed to travel up to 6 kilometers on a single battery charge, carrying out long inspection missions automatically. If the system detects any failure, the robot automatically returns to the starting point and reports exactly where the problem is inside the collider structure. This little robot reveals something curious about science's future. As human machines become bigger and more complex, sometimes the best solution isn't to build something even bigger, but rather something extremely small that's smart enough to explore places where no one else can reach. If you like this episode, leave a like and make sure you're subscribed. Thanks for staying with me and see you next time. Click one of the 2 suggestions on your screen. Thank you. Thanks, bye.